Hey, geometry students. In this lesson, we're going to be talking about the equations of parallel and perpendicular lines. Now, this is a review lesson from algebra. What we're going to be learning here is pretty much exactly the same, except we're going to learn that these are actually postulates in geometry. We have a parallel lines postulate. It says that if two lines are parallel, they have the same slope. However, we have to stipulate that if the lines are vertical, because we can't define the slope of vertical lines, all vertical lines are parallel to each other. That sounds like it's going to be something that's useful to remember for a future proof. And then the same is true for perpendicular lines. We have to state something special about horizontal and vertical, especially vertical lines. Our perpendicular postulate for every other line, though, is that if we just multiply the slopes, we should get -1. Now, what kind of numbers, when you multiply them together, you get -1? Take a look down here at the lower right. -3/2 and 2/3 multiply to make -1. Well, anytime you have a number, especially a number that's a fraction, the thing you multiply a fraction by to get 1 is its reciprocal. And if I want it to be -1, one of those fractions has to be negative. And if they're already reciprocals of each other, here's what we would say, that they're opposite reciprocals. Okay, opposite in that one is going to be positive and one is going to be negative. Reciprocals in the sense that one of them is going to be inverted. So the denominator of the first one is the numerator of the second, and the numerator of the first is the denominator of the second. Does that make sense? So these are numbers like 3/2 and 2/3. These are reciprocals, and they're opposites because one is negative and the other is positive. Now, I'm not a big fan of calling them opposite reciprocals because usually for opposites, it's the same number. It's like 2 and -2 are opposites. And why are they opposites? Because if we add them together, they equal 0, or because they're the same distance from 0 on the number line. But this makes sense, right? You can make sense of what we're saying here. And you can easily inspect these two slopes and say, hey, this is just the inverse fraction of this, and one of them's negative. Bam, they must be parallel. Let's take a look at some practice problems and see how these play out in real problems. We're going to be using slope-intercept form for all of our equations. I'm going to point out, though, that there is one other equation form that works well. And here's the thing. Most of the time, most students in geometry are probably just struggling to get by with slope-intercept form because you're novices to using lines. Even if you've taken algebra for a while, you still haven't used the lines enough, done enough algebra with lines to really understand like the nuances of the equations. Some of that's in general. There are some pretty advanced students, and if you're one of them and you want to be fancy with your equations for lines, I'm going to show you a tool that you can use to be fancy. However, if you're a student who's just struggling to get by answering these questions about lines, you could ignore that and always use slope-intercept form, which is probably the handiest form for writing a linear equation so that we can graph it. All right, let's take a look at letter A down here. Find the slopes of the lines that are parallel to line V. Line V is this line in this graph down here. And we see that line V crosses through 0.53 and 0, 1. Well, first of all, I'm going to use the slope formula. Y2 minus Y1 over X2. Let's see, that's going to be 5 minus X1. Let's turn this into a fraction, and then let's solve it. So 3 minus 1 is 2. 5 minus 0 is 5. So we've got the fraction 2/5 as my slope. In other words, my graph, when I graph it, is going to go up 2 over 5, up 2 over 5. And I can confirm from this graph up 2 over 1, 2, 3, 4, 5. So that worked. Now, I need to find the slope of a line that's parallel. So what I'm going to say is parallel is going to have a slope of 2/5. Perpendicular is going to have a slope of negative. Nope, not -2/5, -5 over 2. It has to be the negative reciprocal of the original slope. Okay? So that was an easy one. Let's go on to letter B. In letter B, it asks, are the lines y equals 3x minus 2 and 3y plus 6 equal x equals 6, are they parallel, perpendicular, or neither? I need the slope of both. So for the first equation, the slope is 3 because it's just in slope-intercept form, and I know the number that's multiplying x is the slope. The second equation is not in slope-intercept form, but we can get it in slope-intercept form to easily find the slope. So it's going to be x. I'm going to subtract, let's see, actually, hold on. I'm going to subtract x from both sides. So it's going to be 3y equals negative x plus 6. Whoa, shouldn't I just write 6 minus x? Well, if I were actually solving this as an equation, I would, but I want this in slope-intercept form, and in slope-intercept form, it's always best to list your x with its slope first, and then your constant. Okay, we need to divide both sides of this by 3, though, to get y truly by itself. Y equals negative 1 over 3 x plus 6. Now, is negative 1/3 the opposite of the reciprocal of 3? And the answer to that is yes, it is the opposite. So these lines are perpendicular because the slopes are opposite reciprocals of each other. All right, letter C. Are the lines 4y plus 2x, 4y equals 2x plus 3 and y plus 2x equals 9 parallel, perpendicular, or neither? Well, for both of these, I have to get them in slope-intercept form to easily work with them. I'm just going to rewrite the first equation in its form that's divided both sides by 4 right away. So it's going to be y equals, let's see, 2x over 4 is 1/2 x plus 3 over 4. And then the second equation, why this one's almost in slope-intercept form, it's going to be y equals, I'm going to subtract 2x from both sides right away, negative 2x plus 9. Let's see, are these slopes equal, opposite reciprocals of each other? They're not the same, so they're not parallel. But 1/2 is a reciprocal of 2, and one of them's negative 2. So these are also perpendicular lines because the slopes are opposite reciprocals. All right, on to letter D. Find the graph. Find and graph a line that is parallel to y equals negative 2x plus 7 and passes through the origin. All right, so this one's going to be not too hard. Y equals, let's see, it's going to have the same slope. So it's going to be negative 2x. This is in slope-intercept form, and my slope is negative 2. So if it's parallel, I know the slope is the same. The only thing that's going to change if it passes through a different set of points but has the same slope is the y-intercept. And it passes through the origin. Well, the origin has a y-intercept, it is at y equals 0, right? So anything that passes through the origin has a y-intercept of 0. Therefore, my equation is just y equals negative 2x plus b is 0, so plus 0, or just y equals negative 2x. It says that I'm supposed to graph this one. Let's graph both. Y equals negative 2x plus 7. So I'm just going to type this into GeoGebra to graph it. Negative 2x plus 7. And I'm just going to make sure I state that you should actually draw your graphs out. I'm only doing this because I need a solution for on the computer. Notice that these lines have the same slope. They are parallel, and the only difference between the two is they cross the y-axis in a different spot, so they have different y-intercepts. All right, let's go back to our lesson and do letter E. Find and graph a line that is perpendicular to negative 4/3 x plus 3 and passes through the point 2, 3. All right, well, to make it perpendicular, the first thing I'm going to do is look at the slope. Instead of negative 4/3 x, I need to flip that fraction upside down and make it the opposite. It's going to be 3/4 x plus, and now, I need it to pass through the point 2, 3, but I don't know what that is yet. So I'm just going to say that that's b. It's going to have a y-intercept, and I don't know what the y-intercept is. But to find the y-intercept, all I need to do is plug in a point, and I've given the point 2, 3 as a solution to the equation. So I'm going to plug in 3 for y, equals 3 over 4 times 2 for x plus b, and I should be able to figure out what b is. Let's see, so this simplifies to 3 equals 3/4 times 2 is 6/4. 6 over 4 is the same as 3 over 2 plus b. So b is going to equal 3. I have to subtract 3 halves from both sides. 3 halves is the same as 1.5. So b equals 1.5, or I could say that it equals 3 halves. 3 minus 3 halves is 3 halves. Remember, 3 is actually 6 halves, so 6 halves minus 3 halves is 3 halves. Just a little weird symmetry there that this is the same as this, but it's just because this is exactly half of this number. So when I subtract it, we have half of that number left. All right, so now once I find b, I'm not done. I need to actually write the equation y equals 3/4 x plus 3 halves. And that's my final equation. All right, let's graph these ones. So I'm going to first of all graph y equals negative 4/3 x plus 3. Y equals negative 4/3 x plus 3. And then let's see if we can make a perpendicular line with our other equation, 3/4 x plus 3 halves. So y equals 3 over 4 x plus 3 over 2. Notice that this red line and this orange line are perpendicular to each other. Also notice that my orange line crosses through the point 2, 3. And that's one of the requirements for this graph. Okay, so that worked out. Last question. 2 rowers are canoeing parallel to one another in a stream. The first rower is traveling at a rate of 2 meters per second. The second rower is traveling at a rate of 2.1 meters per second. The first rower is 4 meters ahead of the second rower. Write an equation for both rowers. Will the second rower catch up to the first? Why or why not? Okay, so let's take a look at our equation. So y in this case is actually going to be the distance equals the slope is going to be the speed. In our first rower's case, it's going to be 2. And then it's going to be the distance equals 2 times the time in seconds. And let's see, our first rower is 4 meters ahead of the second. So he's starting at a distance of 4. So this is the distance of the second rower. Let's just do that so that we can keep track. And then the equation for the first rower is going to be first rower's distance equals, let's see, 2.1 t, and the first rower starts at 0 because if the first, let's see, and did I get these backwards here? Let me just double check. I think I put the wrong subscript. There we go. Okay, so the first rower started 4 meters ahead. That means if he's at 4, my second rower has to be at 0. But now, if I think about this, the second rower is moving faster than the first rower. Are they ever going to cross each other's paths, or is one going to catch up to the other? The answer is yes. The second rower will catch up to the first. Their graphs are going to intersect because they're not parallel. And what does it mean when their graphs intersect? They're going to, at some point, have the same amount of distance at the same amount of time. And if their distance is the same, that means that rower 2 is going to catch up to rower 1. All right, so this is my equation for both rowers, and I can draw the conclusion that the second rower will catch the first because their graphs are not parallel. All right, and that's it. You now know enough about finding the slopes of perpendicular and parallel lines to do the problem set.